Hello everyone, welcome back to my channel. The today's topic is the properties of concave mirror. A concave mirror is a spherical mirror. Already I have explained in the previous video. So this is a concave mirror. For example, here this is the outer surface is reflecting coating and the reflection takes place in the inner side, right? Now every sphere, if we take a small part of a sphere, is a plane only. For example, if we discrete it like this, if we omit this, so you can say this is a plane mirror, right? This is a plane mirror, this is a plane mirror. So that means I can consider that a concave mirror is a combination of so many plane mirrors together, right? So this is a concave mirror first of all, and the middle point of concave mirror is also called pole. So this point is a pole, and through the pole a horizontal line you have to draw. This is called principal axis. And remember, in case of properties or in case of ray diagram, must use the scale to draw the straight line, right? So this is the principal axis which is passing through the pole P, right? And let's say this is focus, and the distance from pole to focus is called focal length, and focus to this is called center of curvature, because these two, the gap and this gap must be equal, right? Now the first property is saying that all the parallel rays, this is a parallel rays which are parallel to principal axis. These rays are parallel to principal axis. This is a principal axis. So all the parallel rays which are parallel to principal axis, after reflection from the concave mirror, they will meet at a particular point called focus. All the rays will meet in a particular point, that is known as focus, right? So this is all are meeting at focus. So this is the reflected ray. As you can see, all the parallel rays after reflection, they converge in a particular point called focus. That's why this concave mirror is also known as converging mirror. Okay, so concave mirror is also called converging mirror. The reason is all the parallel rays after reflection, they converge in a point called focus. And why the rays is coming in this side, that is the reason is, whenever there is a curve, you need to know the normal line. First of all, normal means a perpendicular line at the point of incidence. So to understand this, first you need to draw a tangent. So for example, I am taking this is a point of incidence. Now in this point of incidence, you have to draw a tangent. Tangent means it's a line which is just passing that point of incidence. From that tangent, you have to draw a normal line. Normal means perpendicular line. So without drawing any tangent, you cannot draw any perpendicular line or normal line, right? So tangent helps to find out a normal. With respect to tangent, normal has to be made, because normal is making 90 degree with tangent. So what is tangent? Tangent is a line which is passing through that particular point, which touches that particular point only, right? That is called tangent, and it is called normal. And you can see the incident ray and normal is making angle I over here, and angle R is over here. So I and R is equal. So in each and every point of incidence, the angle I and angle R is equal. That means the first law of reflection is satisfying, and the incident ray reflected in normal all lie in the same plane. So this is the two laws that is followed by concave mirror, right? Now at pole, what is the tangent? Tangent is a vertical line at which touches the pole only. This is a tangent at pole. Now with respect to this tangent, this is called normal. So principal axis itself behave as a normal line with respect to this tangent. That's why we know when a line is falling on it, it bounces back to the same path, because this makes a 90 degree angle, right? As I told you, in case of plane mirror, whenever any ray is coming vertically downward or normal incidence, it will bounce back to the same path. Whenever this is a 90 degree, it will bounce back to the same path. The same thing is happening in case of pole. So when any ray is going through the principal axis, it will bounce back to the same path, right? So this is all about the first property. All the parallel rays after reflection, they will meet at point called focus. Now second point is that all the rays which is started or which originates from focus after reflection becomes parallel. That means the just opposite of this, the first property. Means, for example, let's say this is the focus. From the focus any ray is passing, from the focus any ray is passing, okay, and after reflection from that point of incidence they become parallel to the principal axis, they become parallel to the principal axis. Please remember, just opposite of this. Here all the rays, parallel rays meeting at focus, here the rays which is passing through the focus become parallel. So here parallel become focus, here focus become parallel, just opposite the first two properties, first property and the second property. Now here is the third property. In case of concave mirror, this is a concave mirror and this is the reflecting coating. A line passing through the pole is called principal axis. This is pole P. This is called focus F, and this is called C, center of curvature. Please remember one thing, this is called aperture, and the aperture of the mirror should be as small as possible. जितना small होगा उतना अच्छा ray diagram बनेगा, ठीक है? So this should be as small as possible. Now the properties, third property is that when any rays passing through the center of curvature, for example this is a ray which is passing through the center of curvature, please remember after reflection it will bounce back through the same path. That means both side arrow, okay, one is incoming arrow and the reflecting arrow on the same path. So any rays which is passing through the center of curvature, it must bounce back through the same path. Why this is happening? First of all, so this is happening because we know whenever any ray is passing through the center of curvature, it falling on the surface of the mirror at an 90-degree angle. So as we know, whenever any ray is falling on the mirror 90-degree angle, it will bounce back to the same path. So this is a circle, you can say this is a center. From the center to the surface, how to get a 90-degree angle at this point? You have to draw a tangent line, right? So this is making 90 degrees. So that means from the center to the surface. So 90 degree means, so this is center, this is the surface. So to the center to the surface, everywhere it is making 90-degree angle. Means if you draw a tangent, it makes 90 degree over here. Okay, if you draw a tangent in this point of incidence, it makes a 90 degree over here. So that means basically it falling 90 degree on the surface of mirror. That's why it bounces back to the same path, right? This is the third property. And the fourth property is that when any mirror, for example, this is a concave mirror and this is a principal axis, this is pole P, this is F, C, center of curvature, F is focus. Now any rays falling at pole at certain angle, okay, this is the, it is falling at certain angle, okay, it will be bounces back to the same angle. Remember that if this angle is 30 degree, this angle is also will be 30 degree, because you know the pole or the principal axis is behave as a normal at pole. Please remember, principal axis itself behave as a normal at point of at pole, right? And that's why you can see this is simply, you can, if we remove this part and this part, so this is a plane mirror only, like a plane mirror. So when an incident ray is falling on it, it will be bounces back with a certain same angle. As we know, as per the law of reflection, angle I must be equals to angle R. So this is I, this is R. So remember, so in case of concave mirror, this is a concave mirror. So when a ray is falling at pole at a certain angle, that same angle it will be reflected from the pole on the other side of principal axis. This is the fourth property. All the parallel rays which are not parallel to principal axis. For example, suppose this is a concave mirror. This is a concave mirror, okay, and this is a principal axis, and this is called focus, this is called center of curvature. So all the parallel rays which are not parallel to principal axis, they are parallel to each other, but they are not parallel to principal axis. I am just trying to draw three rays so that you can understand. One ray is going through C, another ray is going through F, another ray is going and falling at pole. So I am drawing three parallel rays. So they are parallel to each other, okay. Parallel rays are generally considered as they are coming from infinity, okay. So from infinity जब भी कोई इन्फिनिटी बोलेगा तभी ऑलवेज कंसिडर दैट दिस ऑल रेज आर पैरेलल टू ईच अदर, ठीक है। सो कोई भी पैरेलल रेज होगा दैट मीन्स दे आर कमिंग फ्रॉम इन्फिनिटी. So these three lines are parallel, three rays are parallel, they are coming from infinity, okay. Even the parallel rays which are parallel to principal axis, they are also coming from infinity, you have to consider. Now here they are parallel to each other but they are not parallel to principal axis, right? In that case, first of all, the ray which is passing through the C, center of curvature, it will be bounces back through the same path, okay, as I told you in the last property. And the ray which is passing through the focus, it will be parallel to principal axis, okay, because it is going through the focus, it will be parallel to principal axis. Another ray which is falling at pole, it will be making a certain angle and moving like this. Try to understand this angle and this angle, and this angle is I and R when it is falling at pole. That means these three rays are falling. You can see the first ray which is passing through the center of curvature will be bounces back, second ray going through the focus become parallel, and third ray which is falling at pole, it will be coming like this. And they all the three reflected rays are meeting in a particular point but they are not meeting at focus like this one. So ये वाला diagram में क्या हुआ था? For this diagram all the parallel rays, they are parallel to principal axis also, okay, they are meeting exactly at focus. The first property, they are meeting exactly at focus, but for this case they are not meeting at focus but they are meeting a focal plane. Focal plane का मतलब होता है this is called a focal plane. Focal plane means a plane or a screen which is I am keeping a screen on a focus, then it will be falling at focal plane. Not they are meeting not exactly at focus but they are meeting at focal plane. All the parallel rays which are not parallel to principal axis, after reflection they will be meeting at any point on focal plane. फोकल प्लेन मतलब फोकस के ऊपर एक वर्टिकल लाइन ड्रॉ करोगे, उस लाइन के ऊपर कहीं ना कहीं एक दे थ्री विल ऑल मीट टुगेदर, they all the rays will meet together. So this is the fourth property and this is all about the all properties of concave mirror. Thank you.